Magnetic force on a moving electron. With reference to the figure at right, where the electron has a charge E, at the electron's location, in which direction is the magnetic field pointing? We have a current that is traveling to the left here in this wire at the top of the screen, and by the thumbkin twist and right hand rule, you put your thumb in the direction of the current and you curl your fingers around, you can see that your fingers are pointing out of the page right here where the electron is. One way to represent that is like that. The magnetic field at the location of E is going to be pointing out of the page. In what direction will there be a force on the moving electron? We're going to use our left-hand rule because we have a negative charge. And again, this is going to be difficult for me to do on camera, but with your left hand, you point your thumb in the direction that the negative charge is moving, and your fingers point in the direction of the magnetic field, which is towards the camera. And then when you pat, you can see you're going to pat to the left. The magnetic force will be directed to the left on that electron. At the instant shown, let's derive an expression for the magnitude of the magnetic force on the electron. Let's start with the definition of magnetic force. Everything is perpendicular here, so that's very nice. The magnetic force on a moving charge is equal to the charge times V cross B. But again, since the velocity of this charge and the magnetic field direction are at right angles, we don't have to worry too much about the cross product. The charge is not given as Q, it's given as E. The velocity is given, so that's fine. What about the magnetic field? What did we derive a long time ago? The magnetic field at a distance r, or in this case a distance d, away from a current that's going through a wire was equal to mu naught times the current divided by 2 pi. Now it was r in the original equation, but here it's given as d, so that's what I'm going to write. We know d, we know I, mu naught, and pi are constants. We know E, we know V. I think that should do it right there. The magnitude of the magnetic force, which we said was directed to the left, that's what we said the direction was. I think we're going to get E, V, mu naught, I, all divided by 2 pi